I'm Summers Pittman. My talk tonight is Introduction to Developing for Android Wear. It is also, in general, just kind of an introduction to the platform and a brief survey of wearables in general, smart watches specifically. I'll also include, after the kind of introduction to the platform, several useful examples of applications and what types of things you can do. Here's the obligatory introduction. I'm a senior software engineer at Red Hat. I work on the AeroGear project as an Android developer. www.aerogear.org. It's actually really cool. We've got lots of things for making enterprise mobile services a lot easier, all done in a very open source and interoperable way. I'm a bit of a Google fanboy, but I'm also much more of a FOSS, free open source fanboy. I'm the AJUG web chair, so the broken images you saw are my job to fix. I have a master's in human-computer interaction, and I'm also an avid cyclist. That is one of the things that I really like about Android Wear and the wearable thing in general, is that it's really made a lot of the fitness things a lot better, so I'm bringing a lot of opinions from that. So, without really further ado, there's kind of a long history of us trying to do smartwatches and various wearable things. Google's had Glass. There have been lots of attempts at a watch. This is a commercial for a Timex data link. It's a early programmable smartwatch that if YouTube will load, you'll see some cool stuff. But basically, you'd fill out your schedule and your address books and things like that in an app on your computer, and then you would hold your watch up to it, and it would send wirelessly to your watch, using a camera on the watch, images on the screen, the data that you put in. So you'd get alerts throughout the day based on your personal calendar. You could look up small bits of information. But at the end of the day, it's still a very primitive watch. It's still a very digital, late 80s, early 90s design. Not a really sophisticated thing at all. But it's one of the earliest attempts at this. All right, YouTube, let's stop. Personally, this was my first smartwatch. It was a Nintendo Game Watch I got when I was about 5 to play Legend of Zelda. Unfortunately, for things that involve 5 years old, make lots of noise, and go through batteries very quickly, it met an early fate when my mother borrowed it and never returned it. This was my first actual smartwatch, the Sony LiveView. It had lots of problems and was a very early implementation of the platform. It was basically little more than a second screen for your smartphone. There were several apps that had hooks into it, so as long as your phone was connected, it could do a lot of things that we would recognize. You could look at your emails, you could look at your Facebook messages, you could send very simple replies back. But if the watch came unpaired from your phone, it would forget what time it was. So about a year after I got that, I got a Moto Active. And this is where wearable technology has really seen the most success, is in this sort of fitness category. Everyone seems to be having a fitness band or some sort of fitness wearable that integrates in with a lot of peripherals, integrates in with Android or iOS, and then connects to a whole bunch of services based around fitness. Fitbit and Microsoft have bands as well. There's Nike Fuel Band and lots of others, and they all do a really good job of bringing something more to the smartphone experience and kind of making the computing know more about you personally, which is a lot of what Android Wear will capitalize on, as being a very personal, this is you device. And in addition to the smartwatch things, there's also been other there have been other companies which have tried things. We have Pebble on the left, which uses an e-ink display. It's very, very sophisticated. It has an open API. It's been very possible. It's actually my favorite smartwatch for most people, because it's very simple. It has very long battery life. It's not very it has a lot of elegance in it. Plus, you can get the pebble steel and it looks very snazzy. On the right, we have the Samsung Galaxy Gear, which followed the Samsung motto of putting everything in there. There was a camera in it, there was a microphone in it, an accelerometer, GPS, but it had the touchscreen LCD screen that we see in the Apple Wear and the Android Wear watches, the Apple Watch and the Android Wear watches as well. And it came out about a year before Android's watch. So for Android Wear specifically, at Google I/O in 2014, Google announced Android Wear and 3 watches that would go with it. The Samsung Galaxy watch, LG's G Watch, which is what we're raffling off today, or raffle, whatever Twitter raffle's called, traffling, and the Moto 360, which is actually a round smartwatch and is kind of snazzy. And so that really got a lot of that was really the first time we had seen what Google's answer to this was, and the first time we had seen the Android Wear platform. So, beginning a night of puns, the introduction to to Wear, specifically the hardware. Google decided again to take the partner route that it had done with Android to much success. Right now there are watches by Samsung, LG, Motorola, Asus, Sony, and several more that I can't remember. They're all on Google's websites. The watches use Bluetooth LE, so they're very low on your phone's battery life. I've personally found that my phone gets a better battery life with the watch because I'm looking at the notifications on my wrist instead of powering up the screen on the phone, bringing the phone out of sleep. So I end up actually getting better life despite the fact it's tethered on Bluetooth the whole time. Unfortunately, Bluetooth LE is something that is only found in Android 4.3 and higher, which means it's not even available for 40% of Android devices right now. As I mentioned earlier, Android Wear uses bright color screens with touch-based controls. They also have a microphone for voice input. The screens are round or square, so you get these different shapes in addition to having lots of different devices with lots of different capabilities. And then we have the various input mechanisms. You can do it. All my Android Wear devices have a microphone, so you can actually talk to it, ask it simple questions, give it commands, give responses to whatever notifications you're getting in. They all have sensors. They have different sensors per watch. As I mentioned before, there's a lot of fitness interest in this space. So there's things like a heart rate monitor, a pedometer, an accelerometer. Some of them even have GPSs for offline run tracking. This is something new in Lollipop for the Android Wear. And they come in various styles. In the round watches, for instance, there's the Moto 360 and the LG G Watch R. Yeah, that's a mouthful. The Moto 360 really spent a lot of time on having a very nice, very jewelry accessory design. The LG G Watch R took a much more kind of digital watch, that more, I don't want to say low-end Casio, but it has that big rubber look, that very, kind of rugged look. Most watches use standard watch bands that you can replace with any other watch band on the market. They have usually contactless, or they have sealed charging, so you don't plug a micro USB port in, you put it in a special adapter. Some of them even have wireless charging, like the Moto 360, which uses key wireless charging, which is a wireless standard, so you can get a charger for it for about $5. Unfortunately, most smartwatches are very, very large. I am blessed with a nice thick wrist, so this doesn't look silly, but one of my roommates, she's also a developer, and the watch actually hangs off of her arms. So that's one of the things that's still kind of an ongoing issue in Wear, is the style of the physical devices, because you can only make them so small before they become silly and difficult to use. The software for Android Wear. So unlike other watches and unlike other Google products previously where they used a fork of Android, this is actual AOSP derived Android. You can find the hooks for it in the AOSP tree. You can check it out. You can make your own images, and you can run them in the Android emulator. When it launched with Android KitKat 4.4, and right now, as we speak, Lollipop is rolling out. Some of my devices have it, some of them don't. So that means this talk's going to be a little bit out of date. It won't cover some of the new features in Lollipop, unfortunately, but there's only so much I can do with 4 days from when it started wearing out. Most of the software uses Google Play services to talk to the phone, and it makes a nice, lots of easy services available to Android and to the watch for syncing data back and forth, sending messages, sending notifications. And since it's in Google Play services, this means that it gets pushed out to all Android devices at once, and you don't have to wait for carrier updates to enable new functionality and new features. This is why, for instance, older versions of Android can still do the Android Fitness, can still send notifications to the device without having to have the updated things found in KitKat or Lollipop. This unfortunately means that the applications are less open source friendly because Google Play Services is a proprietary binary blob. So while you can distribute the source for your application, people will still rely on Google's proprietary technology to actually make it work, even for a lot of the more simple applications. However, Google does also provide there are several open source libraries and several libraries available to help out. Google has a set of UI tools for Wear that are really nice. There's also a couple of projects in the community. One of the ones that I've come across is called Teleport, which is a data synchronization toolkit. I haven't had a chance to really use it, but I do find that it is very encouraging to see that there are projects in the open source from the community that are getting feedback and getting help and getting lots of traction already, even though it's been out for less than a year. Applications for Wear are available in the Google Play Store. They are bundled as companion applications with an Android app. So, for instance, if you use Evernote, when you download the Evernote application on your phone, if you have Android Wear paired with your phone, it will install the Evernote application on your watch as well, and that integration will happen seamlessly and quickly. Android Wear has lots of really just walking around with Android Wear in the day-to-day life, as I mentioned before with the Timex watch, where it was trying to keep track of what you were doing, and where Timex was trying to keep track of what you were doing, Android Wear also tries to give you very nice, important information at a time. I forgot who I was talking about earlier. I think I was talking to Burke, and you were saying you were trying to figure out things to do with it. So one of the things Wear is really awesome for is traveling. It can show you your Google Now cards or your Android navigation or your Google Maps navigation alerts. So when it's time to make a turn, your phone will vibrate, and your watch will vibrate, and you can just look at your wrist and see what you're supposed to do instead of having to fumble with your phone. If you fly a lot, there's flight information that'll get pushed to your watch through Google Now. And also it preemptively sends you alerts. So if there's traffic on, say, 85 north or 400 heading towards 285, you'll get an alert saying, hey, you said you were going to be here, but traffic is going to be bad, so you need to leave earlier. For exercising, as I mentioned, there is a lot of fitness. You can get, some watches have GPS support, which will actually track your run like the Garmin will. Most of them have kind of ambient step monitoring and heart rate monitoring that give you this nice feedback throughout the day. Hey, you're 30% through, your daily exercise, 50%, 100%, and gives you lots of nice graphs on that. You can also just do it for slacking and relaxing. Some watches have, with Lollipop, you can actually download music to the watch and play the music through Bluetooth headsets. You can control music with any sort of player that sends the right commands to the watch, like Google Music. You can also use it to control various remote devices, answer phones, send quick text messages, things like that. And also it just gives you handy tips throughout your day. So if the weather's changed, you can get the weather alerts. If you have a reminder and something's coming up, if you want to set a timer to make sure that your tea gets cooked correctly, you can get all of those through the watch, and it's just very nice, very convenient. You always have it with you, and once it's done, it's out of your way. Now that I've kind of talked about this thing for a while and how it's great and awesome and really nice, let's talk about actual development. What I'm going to talk about is the UI paradigms, things you have to keep in mind when making apps, and the tools that Google makes available to you. And then I'm going to go into several code examples of actually how the apps work, how you do these separate things. And it's 4 very small demos. All of them have 1 or 2 classes to look at. So it shouldn't be too hard if you're at least passingly familiar with Android. This is the Google Wear design page. If you're doing anything with there, I suggest you start there and read it, and if you type Android Wear design into Google, it'll be the first result in Google. But they give you lots of resources that are very, very good. You get lots of very good resources. You get lots of very good animations, images, iconography that you can use, and it's a great, great resource. So there's several ways Android apps can work. The very simplest one is the Android Wear application is nothing more than a viewer for notifications from your phone. This is actually very, very awesome. This can let you write application code that exists entirely on your phone. You don't have to build a Wear app at all. There is 0 Android Wear code embedded in it. You don't have to link against Google Play services. All you have to do is include the support v4 library in your APK, and then you use its notification builder, and you can plug in extra hooks that Android Wear knows how to process to do things like get simple responses, enable a voice response, and also do basic design of the notifications on your Wear device. Just going back here, all of these are not applications running on Wear. They're actually notifications being pushed from the phone using this mechanism. One important note is you have to be very careful not to annoy your users. There are some apps which, for whatever reason, think that you need to be aware of every single thing that can possibly happen. 32 pokes, 18 likes, 72 messages, and someone posted 400 individual posts on Facebook. That could add up really, really quick if you're not smart about it. So you have to understand how the notification folding and embedding works. That's a little bit beyond the scope of this talk, but it's something to be aware of that the Android docs actually cover. Back to don't annoy your users. What doesn't annoy your user? You want to do things that delight your user. You want to have any information you show them be relevant to what they're actually doing or to what's going on around them. You want to make sure that your notifications are glanceable. What that means is that you can look at your wrist, you can see what it is, and you can get about your day in about that long. You shouldn't have to interact with a notification to really get any meaningful information out of it. You shouldn't have a lot of things you can do in response to a notification. So if someone sends you a meeting invite, having a yes or no, accept, decline button is fine, but having perhaps a 8-page form that you have to fill out to explain why you declined and things like that is wrong. Another important thing to know is to use your white space effectively. You're getting something about that big to look at, and you don't want to have it entirely packed with so much information that the user has to look at it and figure out what you're actually trying to say. You want your message to be big and bold and in front of the user. But if you actually want to make an application and not just a notification, there are lots of custom views and lots of tools that Google provides to make using the Wear interface a lot simpler. There's a big difference between a phone and a watch. The watch, you can only get very small, very fine motions. So there's several UI patterns that Google has made very easy to implement and given you several extra classes in the Android Wear support libraries. There's box insert layout, there's watch view stub, and wearable list view that all know that they're on a watch, and they all do several things to help with things like, is this a round device or a square device? Is the user scrolling slowly? Is the user tapping on something? And it's one of those things that you really need to just play with the device and play with the various examples to really see all the subtleties that it does. And then there are a few, and then for more complicated apps, there's this grid view pager, which is, well, basically a grid view of rows and columns that make it very easy to swipe through up and down and left and right and load things into and out of memory correctly and efficiently and make for a nicer, easier user experience. As far as the actual coding goes, most of your coding will be done in Android Studio. You have to, this is all supported in Android's Gradle tooling. I don't think there are ADT and Ant tools for this. One of the big downsides is you need a physical Android device, a phone or a tablet, to run the Android Wear app on to be able to connect to either an Android Wear emulator or an Android Wear device. The internet claims that it has gotten Genymotion working with the Android Wear APK. Google makes no such claim, and all of their documentation refers to using a Android phone or tablet to control and sideload apps to the watch with. But you can use a watch or a emulator. You don't have to have the watch, but you do have to have a phone. For getting support for Wear into your applications, if you're only using the notification app, there's one line in your build.gradle for your Android app that you include, and that's the support library, which you're probably already including anyway. If you're making a wearable app, then in your support library you want to link to the app with Wear App Project and then include Google Play Services. And on your wearable project in Gradle, you will want to include the support library and the wearable support library and the wearable Play Services library. And I'll discuss that in a minute. So that concludes the me standing up and talking portion of this talk. Well, me reading off the slides for you. So this is a very, very simple, okay. So so just the way you'd start making an Android Wear application is you'll start a new project in Android Studio. Has everyone here used or know what Android Studio is or used it? Okay. I have not seen any support in any documentation for doing this in Eclipse. There is all of the possibility that you can make Eclipse work this way, but I don't know if things like the Android Wear support libraries are even available outside of a Maven repository. So you'll actually have to do a lot of work to get this support into Eclipse. Please, please, please don't use Eclipse. Android Studio is amazing for Android development. The big thing that it fixes is by moving to Android Wear, I mean not Android Wear, but moving to Gradle, you have managed dependencies now, so you no longer have to import all of these separate projects into Eclipse and get all of them compiling inside of Eclipse and then get your project linked to it, and then God forbid you have to onboard a junior developer and teach them how to do this. It's miserable. Whereas with this, you open up the project in Android Studio and you start coding, and it figures out all of the dependencies behind the scenes. But anyway, that's a lie. So yes, Eclipse does support Gradle. Eclipse's way it handles things, building applications that aren't Eclipse is very, oh dear, is very messy. You end up having to have a lot of support, and it doesn't work as well as it does in IntelliJ. It doesn't work as well as it does in NetBeans, and it sure as hell doesn't work as well as it does from the command line. I really, really, really hate Eclipse.
Can we use the Android Studio for device apps, or can you have to maintain two environments there, one Eclipse and another Android Studio?
Yes, you should be able to do that. I'm not sure how, but you should be able to do that. You, in theory, could do all of your app development in Eclipse and then do the Wear development in Android Studio, and then have just a Gradle file to build your Eclipse Android project, build the Android Wear APK into that project. You should be able to do that, but I have no idea how, and that would make an awesome blog post. You can also do just regular Android development, Android Studio. Really give it a shot, but at less Eclipse bashing. It's one of my favorite hobbies. But so anyway, so let's just create a new Android Wear application real quick. We do the new project wizard in Android Studio. Here we can select that we want a phone and tablet application and a Wear application. I'm going to set both of these to Lollipop, just to make a lot of things look simpler. Let's include the Google Play Services activity. Sure. Create a basic activity for Android Wear. Yeah, main activity sounds good. And the various Gradle tooling fires up, creates the project, opens it up in Android Studio, and then immediately sends the window to the back.
You picked 5 because a lot of the stuff for the small devices is going to be in the newer.
I picked 5 because if you pick 4.3 or 4.4, then Android Studio will include a lot of the support libraries and set all of that up for you, but it makes it a lot harder to walk people through the code and explain where Android Studio and, Android app, the Android app and the Android Wear app hook into each other. So I'm just doing it for simplicity right now. It has nothing to do with any sort of special support. As I mentioned before, the Wear app is its own APK that's bundled with the mobile app, and you get 2 separate projects in Android Studio. Let's actually go to the file system layout. Oh, sorry about that. Yeah, that's enough. That's enough of what we're trying to show off right now. So you have your mobile app and your Wear app as two Gradle projects inside of your main project. This is a standard Android Gradle layout with your manifest and your build.gradle. One of the cool things in the build.gradle is, as I mentioned earlier, you reference your Wear project using Wear app project. This is all done for you by Android, but just knowing kind of the few things that are actually different between the two. And then you have your separate Wear project here, which is just an Android app. You have your Android manifest, you have your layout resources. It gives you a default round and rectangular view. Round view. And then if I were to hit run on this, it would go to my phone. So my phone and a emulator. One of the things you have to do in the emulator is, if you're running an emulated Wear instance or if you're doing Bluetooth debugging, you have to use ADB to forward the local debugging port to your phone using ADB-D forward TCPs blah blah blah. That's documented on Google's site, and just make a quick alias for it if you're running a Unix flavored command line. If you're doing Windows, I don't have any help for you. Actually, no. If you're using Windows, you can make a PowerShell script to do it for you. You can put it in your Windows profile. You can put the alias in your Windows profile. You can run Command Z. You can run Cygwin and get a bash shell. There's lots of things you can do, but I think most everyone here is using a Mac, so just put it in your Linux. Your bash. Just make an alias in bash. So now the phone should be connected to the emulator on my device. Yep, it's connected. And Oh, let me dismiss. So since Android Wear is a lot slipperier than it is in, since Android Wear has a lot more things built into it, and since it's more dependent on the phone, when you connect your phone to the Android Wear app, it'll start receiving notifications from your phone. So I was dismissing a whole bunch of things my friends had sent me. But yeah, I mean, and then we just hit run, and the app goes. We can either run the app on the phone, which it's laboriously getting around to building and doing. Oh yeah, Gradle didn't make any of the Android build cycle faster, which is sad. It could also be that I have 5 Android Studios running right now. Ah, there we go. So this is the phone app, and then if I run the Wear app, by selecting the Wear run profile, it will pop up in a few minutes and ask me to select the Wear emulator. See, this is the fun part about doing these demonstrations is you're standing up here hitting the run button and waiting for it to do something, and you have to find ways to fill the time. So, does anyone have any questions so far?
What kind of processor you got and memory do you have on the machine you're running this on right now?
I have so this is a ThinkPad T420S. It's about 4 years old. It has a 2.5 gig-ish dual-core i5 with hyper-threading, so it's got 4 virtual cores, and it's got 16 gigabytes of RAM. So most of this is just waiting for Gradle to get around to doing things. Gradle is slow for Android. The Android build chain is very, very slow because what it has to do is every time all of the Java dependencies have to get compiled to a DEX bytecode, then the DEX bytecode has to get assembled into a single classes.dex file, then it has to be packaged up with the rest of the resources, and then those resources have to be installed on either the emulated device or the actual device. And it has to do this every time, and it's very, very slow. Google is working on this with a new intermediate representation bytecode, so that now everything gets compiled to the IR, and then the processor can, and then the computer can very quickly assemble that into the DEX and deploy it, and you lose that recompile every time step. So we've deployed our application to the emulator, Hello Round World. If I had a square thing up there, it would say Hello Square World. I'm not going to go through all of that again because that would be horrifically boring. But yeah, so to create just a skeleton Android application and the skeleton Wear application in Android Studio is very, very easy. You just tell it you want it, click through the dialogues. And like I said, it's all Android activities, it's all Android layout files. There's a few extra things that you can include. If I wanted to, I could deploy any Android APK to the watch. It may or may not work because watches lack things like the Wi-Fi radio, and you have to use the phone for net access and little things like that. But it does actually work. You'll get your action bars, you'll get all of that Android stuff on your wrist, which is kind of cool. Real quick show of hands, how many people have done any sort of Android development? Okay, a little less than half. All right. What questions do you guys, what things did I like jump over that you might want to hear before I move on?
So that wearable, that was a that emulator that you had.
Mm-hmm.
That wasn't an x86 emulator. That was actually running the.
That's an x86 Android Wear emulator.
Oh, okay.
Yeah, it's anything that can run Android can have Android Wear compiled to it. Android Wear is just a build flag for AOSP.
Okay.
And
so it wasn't a ARM emulator. You know, like people move away from that because it's so darn slow.
yes, it is. It's terribly slow unless you don't have KVM. Then ARM, I think, is still faster than the x86 emulation without the hardware virtualization support. That's important if you're doing any sort of cloud-based building, like if you use Travis or CloudBeast for continuous integration. It actually ends up being better to use the ARM processor because it's easier to emulate than the x86 processor is.
Using the KVM extensions.
If you don't have the KVM extensions. If you have the KVM extensions, use the x86 emulator. You will thank yourself.
And then the other question I had is can the actual device, the wearables like the Moto 360, can it run ARTS, the new runtime environment?
I'm going to say yes, because it's getting Lollipop, and Lollipop is the new runtime. So I haven't seen anywhere where Google's keeping Dalvik around for Wear. I think a lot of things that ART was done was to make Wear work better. So yeah, I'm going to say yes, but there's an asterisk in that I don't have a firm exactly yes, this is it. Other than Google said ART is the Android 5 runtime, and Android 5 is coming out to the Wear devices. So I accidentally closed my emulator. So let me pull it back up real quick. And this will be one of those things where real quick actually means real quick. Oh, sorry, Burke.
Automated testing and debugging.
Yeah?
How do you debug a Wear application?
You attach, yeah, it's like any other Android app. You attach the, so there's, how hard do you want me to make this for you? Not. You press the debug button and say run the Wear app, and it connects everything up. If you are a masochist or a particularly tech-savvy person, you can actually you send an ADB command to fire the application up in debug mode. You can use DDMS, which is Android's device manager, part of the Android SDK, to connect the Android debugger to an open port on your computer, and then you can put any old JVM debugger on it and show it your source code, and it can work. So you can debug in what's a god-awful IDE? Yeah, Eclipse, NetBeans. I actually do Android development in NetBeans because I hate Eclipse. So all right, what I'm going to show off now is how you send those, what notifications look like when they come into the Wear device. As I mentioned earlier, you do need a phone to sock puppet everything. So I'll be using my phone up here from time to time. And I won't really have, and I won't be able to show you the screen because Android screencasting software kind of sucks. Because it's really, really easy to get a screen grab every few seconds. So that's kind of the state of the art. And now I get to dismiss my notifications again. All right, so so what I'm going to do is I am going to go to so I'm going to use AeroGear's Unified Push Server to send a message to my phone, which will be displayed in the emulator. If I may have a second for a shameless plug, Red Hat sponsors the AeroGear project, and AeroGear has made a Unified Push Server for basically just giving you very easy access to push technologies. It's basically your own private urban airship. Probably less sophisticated because I haven't used Urban Airship. But what I can do is I can select my to-do application. I can send it a message to put in, this is a test, and then I can send the push notification to my phone. The phone will put it on Wear, and it'll show up on my watch really, really quickly. And then if I dismiss the notification from my phone, Android and Wear have notification synchronization, so when I dismiss it from my phone, it goes away on my watch. If I dismissed it from my watch, it would go away on my phone. So that's kind of neat. And it's really easy to do. Go away. And it's really easy to do. All you actually need is for whatever builds your notification. In this case, I have a broadcast receiver. all you need to do is make your notification standard-like, and it automatically shows up. As I mentioned earlier, there are extensions for where that you can include. Right now I have set the background on where, and I have turned on a couple of UI hint. In the wearable extender, you can also set things like what responses you can do. You can give it the prompt to give voice back. And then you just put it in the extend method on your notification, and then you send it. And this is all Android code. This is all running in an APK. This is not any Android Wear code. This is not running on the watch. So in this particular case, you'll only need one APK. You can very easily add it to any project you're already doing and get that win right there. So that's actually really nice. Let's say we want to do something a bit more complicated. One of the things that I mentioned earlier was that you can use Android Wear to control devices on your Android device, or if your Android device is paired with something else, you can use Android Wear to send messages to those devices. The way this works is it's basically an RPC, well, I say RPC. It's basically a message passing, it's a message queue that's implemented on Google Play Services. You will attach a message, you will sign into Google Play Services, call the connect method on it, you will, and then just use it to send messages, and you'll register receivers on both ends and things. When I say Google Play Services, how many people have no idea what I'm talking about? Okay, 1, 2, 3, 4, 5, 6. Okay. Google Play Services in a lot of ways is Google's answer to Android fragmentation. It's moving all of this, it's a separate APK that's moved all of Google's services out of core Android. It is updated outside of the standard Android release cycle. It has more than 95% of Android users are on the latest version of Google Play Services. And the way it works is it's basically a program it's basically an APK that's running in the background in Android, and your application will connect to this the Google Play Service application and disconnect from it as part of its natural life cycle. Whenever you need to, say, send a message on Android Wear, you'll get a connection to Google Play Services, you'll put the message in, and then you'll disconnect from Google Play Services. So that's what it is, and that's what it does. Yes?
So if that's how it works, then what happens if you're out on the network or Wi-Fi?
Google Play Services is running locally on your device. So when you get a connection to it, you're getting a connection to the Google Play service running on your device, not getting a connection to Google services out in the cloud. For those of you who don't know, anytime you want to run code in the background in Android, you create a class called a service. 90% of the time when I say service tonight, it's going to be in that context of something running on your device that you can connect to. Okay, so the way you send commands from a Wear device is using the message service, the message APIs. This actually has to be implemented on your device and on your Wear device. It is implemented as either a service or an interface on an activity. And what you do is anything that wants to receive a message implements the Wear listenable service or implements the message listener callbacks, and then they register themselves as listeners with Google Play Services. On the sending side, you just get a connection to Google Play Services and you send. So for my project, for a demo, one of my coworkers, Daniel Passos, made a Chuck Norris fax fetcher that uses a remote web service to fetch a random Chuck Norris fact. Now, I thought it would be cool to add to this application the ability to send those facts to a Android Wear device. And the way the application looks is you load it up, swipe right to fetch a joke, you click fetch joke. This sends a message to my phone, and then the phone fetches from the server the new Chuck Norris fact, then it sends that fact to the device using a separate message. When Chuck Norris was denied an Egg McMuffin at McDonald's because it was 10:35, he roundhouse kicked the store so hard it became a Wendy's. I'm glad. Yes. Okay, so I'm easily amused and I can play with this for a while. But let's actually get into the code. So we can start either on the Android Wear side or on the Android application side. Both of them are very, very simple and I can get through in a couple of minutes, but where would you guys like to start?
Android application side.
Android application? Anyone else? Going once, going twice? Okay, awesome. So Chuck Norris jokes. So the Android application is 3 classes, a application class. Oh, did it again. So the Android application is a standard Android application. It's got the activity class where I set up my connections and I set up my data fetching service called a pipe. That's an AeroGearism, not an Android Wearism. It has a activity where you can actually fetch the service and where you can fetch the joke from a remote web service, and then it has the wearable listener service that waits for a message from the wearable, fetches from the website, and then returns the message to the wearable application. I also have in my manifest, I have one of the important things that I keep forgetting is that your package ID and your application ID have to match on both the Android Wear device and your phone, otherwise it will silently fail and you will beat your head against a wall for an hour trying to figure out why messages aren't going from one to the other. So anyway, this is what the joke fetch listener looks like. And this thing wants a reinstall. This is what the wearable listener service looks like. Okay, so the wearable listener service connects to Google. So the wearable listener service is a broadcast receiver. No, it's not. It's just a service. Android will. The wearable listener service connects to. The wearable listener service connects to the Android services like everything else, the Google Play services like everything else. Google Play is responsible for activating the service. In your manifest, you have to include a special intent filter. And I don't know why it's having trouble. So in your manifest, you'll have to include a special intent filter so Google Play services can connect to it. And then in your wearable listener service, you implement the on message received method, which is called by Google Play services whenever it receives a message from your Wear device. You're able to extract the information into that method, and then you can act on it. So if you need to make a local change, you can. If you need to make a remote change, you can. If you need to send information back to the Android device, to the Wear device, you also can. In this particular case, that's what I ended up doing because the Android Wear device itself can't make that remote network call. Well, I couldn't make it make the remote network call. Google's docs imply you can open raw socket connections on your Wear device to connect to remote servers, and they ask you politely not to do it.
In addition,
So I mean, besides Bluetooth, does it also mean it has a Wi-Fi
there's
built into the hardware?
there's no reason it can't, but
Good question.
the question in addition to Wi-Fi, in addition to Bluetooth, does it have a Wi-Fi radio? It can. There's no reason it can't, but typically it doesn't. The libraries themselves come with a lot of support for communicating over the Bluetooth channel using Google Play services. It is possible that you can connect using Bluetooth LE to other devices as a networking port and send data that way. So I'm assuming that's what Google's talking about in their docs.
But you can still get there just by proxying through your phone.
Yes. Well, proxy is a strong word for it. The easiest way to get there is to send requests to your phone over Google Play and have your application service them. So it's not going to be like a Squid proxy or a SOX5 proxy, or you're not going to be able to open raw sockets on the device or make raw requests on the device. You have to send the request to your phone for your phone to handle it in its own thing. Did that make sense? Yeah. Okay. Okay, so this guy looks a lot healthier. So in addition to the Chuck Norris fact, which was an example of using the remote message system to send messages and get them back, there's also a data synchronization service that uses whole objects in a database to synchronize between Android and the device. In this particular case, I've taken free OTP, which is a Fedora project. OTP are one-time passwords. It's like Google Authenticator or the little dongles you get from RSA tokens. And what this does is it synchronizes your OTP database with a database on the phone, on the watch, so that you can use your watch to fetch your OTP token. And the synchronization is robust enough that even if you become disconnected from your phone, you can still access this token and still update this data. And when you come back in to get connected to the phone again, the synchronization will happen. So as just a quick, as a quick example, let's fire the emulator back up because it died. Demonstration, whatever. You'll go through a lot of the same things, setting up the data synchronization service. You'll extend either the wearable listener service class, or you'll implement the message listener APIs. In the case of the wearable listener service, you can override the onDataChanged methods, which are called only when data changes. So if you commit the same change 3 times, but you don't change any data, only one packet gets sent to your phone and only one call to this method happens. So if you are using it to poll or trigger some activity on your device, you need to send some sort of timestamp with it. Again, we'll start with our Android APK. This is the implementation of the wearable listener service on here, token sync service. I have listeners for when the watch connects and disconnects. This is managed and called by Android. onDataChanged is, as I said, whenever you update your token on your device, whenever you get the next token, it is alerted of that behavior and is able to update its internal token count for figuring out what the next token to display is. The data events give you you can extract from the data events object, that is the data event buffer, which is the parameter here, a list of events. What the freezable utils do is they just make a copy of the object so that the buffer can be reused by Android Wear or the Android operating system. And here we get our Google services connection. So we get the Google API client. We request the wearable APIs. This right here is really important that you do some sort of locking check around it to make sure you have Android Wear, because if you don't have Android Wear on your phone, then the app will crash here. And that's why it doesn't work in the emulators, because the emulator doesn't come with the Android Wear app. You get the node of the, and then after you get your connection, you get the node for the device that this code is running on. Nodes are basically Android Google Play Services concept of endpoints. So your watch is a node, your phone's a node. Messages are sent to nodes and from nodes. Then you iterate through the events which came in, and here is where you do your synchronization locally and act on the changes. So if the event was triggered from the local device, ignore it. If it wasn't, then that means that the phone, that the watch was sending in a new token count. And what we do is we fire up our token database. We extract from the event the data map item, which is the object that you put your data into that gets synced back and forth. And then we get from the data map our key sets and our values. And one of the values is a JSON serialized token. Then that token we save in our persistence, and then we, after all of this, disconnect from the Google API client. So what that means is I can, on here, look at this particular token. This is a timer-based OTP token, and I can click on it, get the token, and then on my phone, I can, where is free OTP? And then on my phone, I can create a new token and call this test2, give it some BS data, and then I add it, and it shows up immediately on the Wear device, and I can and then I can get the, and then when this times out, I can get the next token and it disappears from there, and they stay in sync with each other. So whenever this token changes, the next token this one gets will be the next token. Yes? 5 minutes? Well, good, because that was my last demo. Yeah. Sorry about the technical difficulties, kind of in the middle there with the Chuck Norris app. The Android Wear application has pretty much the same wearable listener service that you implement, and you can consume messages from the phone and consume data synchronization events from the phone. All right, so with that out of the way, any questions? Yes?
For Android apps, we use HTML5 technologies and we bundle with PhoneGap. So can we do the same for these?
Repeat the question.
So the question is, can we use PhoneGap in Android Wear? The answer is, there is definitely a way. Please don't. So because Android Wear is Android, you can put the shims in there. I don't know if Cordova has any support for it whatsoever. And if Cordova doesn't, then you're going to be on your own. But really, like the grid page viewer and the grid layouts that Google provides for Android Wear are so much easier, so much faster, and so much better than anything you can come up with with Cordova, that I'd say you just use them. I also hate Cordova almost as much as I hate Eclipse.
Are there any examples of apps only on the Wear without a device?
No. So that's a very qualified no. The way you install apps on the device as a consumer is you download the app and install it on the phone from Google Play. Now, the app can just be, the app that's installed on the phone could have no activities, could have nothing launched from it, and not show up anywhere on the phone other than in your installed applications list, so that when you uninstall it from the phone, it uninstalls from Wear and everything's on Wear. But I'm wrong. Android Wear, as of Android 5.0, got a watch face API. And I think those are installed entirely on the watch, with sometimes a companion app on Android. However, I've not done any studying on this, because that came out 4 days ago.
Can you recommend something like we use TestDroid right now, but I don't think they have any kind of, like with our espresso test, they don't have any kind of hooks for that. Can you recommend any kind of testing that would work with these devices?
So can I recommend any testing? The short answer, or any automation testing. Android has built into it The Android SDK has a JUnit based instrumentation test runner that you can sock puppet through Gradle to get information out of your testing, which probably doesn't suit you that well. There is also Roboelectric, which implements a lot of the Android shims, so your pure Java code can be tested. Anything that doesn't require, anything that you can abstract away from your Android code, so anything that doesn't require context or anything that can have the context mocked, anything that doesn't require like Google Play services or can have those mocked, you can use Roboelectric and JUnit 4, any of your other Java tools to great effect. One thing to note is that the Android Gradle plugin is incompatible with the Java Gradle plugin, so you might have to contribute to some open source projects to make this work. Any other questions? Yes?
Does this device support any browser?
Does the device support any browser? There is no web browser on the device. You probably wouldn't want to read a web page on the device. There is rudimentary access to Google Search built in, where you can do a voice search. It'll bring up it'll bring up several results, and then you can open those results on the phone.
What's the longest battery life on this?
What's the longest battery life? So I get about a day and a half on my Moto 360. My LG G Watch gets about 2 days. The G Watch R has been reported as having 3 or 4 days. To put that in contrast, a Pebble has about a week. Your mileage may vary based on usage and different settings. When I first got this, I put it in beat the watch like it stole something mode, with the screen brightness turned all the way up, the screen always on, all of the animations always working, and screwing with it, and was able to kill it in 6 hours. So that gives you an idea of like the amount of control you have and the amount of things you can turn on and off to extend that battery life. All the way from 6 hours beating the watch as hard as I can to a day and a half of casual use on the same hardware.
And they're waterproof too, like you can exercise with.
The Moto 360 is IP67 water resistant, which means it's good for up to 30 minutes at a meter pressure. And it's also pressure resistant, so if you're like spray it with water, water won't get in, which is good for things like showering or washing your hands, or and then the 30 minutes dunked underwater is good for swimming or washing a car or something like that. Any more questions? Going once?
Are there any apps that are oriented to the watch actually being on your forearm versus it being some folks wear it here?
Are there any apps that, so the question is, are there any apps that take advantage of wearing the watch on your wrist, on your palm side instead of your hand side? The answer is I don't know. I don't think there's any downside to doing it that way, but I don't think it knows enough to have any, there's nothing I've seen that said, oh, you're wearing it on your palm, do this instead.
It works both ways. At least the Moto 360 does.
What are the platforms competing with Android Wear?
What are the platforms competing with Android Wear? There's Samsung Tizen, there's Pebble, and then there's this rumored Apple Watch that isn't for sale and is going to be about a year late to the market. So let me tell you real quick that if you aren't sure about Android Wear, buy a Pebble, because it's brilliant. It's phenomenally, awesomely brilliant. Android Wear is still getting into its second version. The first version was really, really good, especially for a first iteration of a product. I don't know how 5.0 is going to be, but it probably is going to get better. With that said, Pebble has been out for a lot longer and has a lot more time to mature and has a lot more apps available for it. But Android Wear is still phenomenally awesome if you have an Android phone. If you have an iPhone, get the Pebble, hands down. You won't regret it.
Do any of the phones have like a heartbeat monitor or anything like that built in?
Do any of the phones have a heartbeat?
The wears.
Do any of the wears have a heartbeat monitor built in? Yes, this one does. It's kind of flaky. You're better off, like, it's good at telling your heart rate has gone up, your heart rate's gone down, and turning on the ear exercising counter. But if your heart rate, if having an accurate representation of your heart rate is really, really important, then you probably want a different, more purely fitness device and get an Ant heart rate monitor. There was a question there.
Have you found a good wear app yet?
The question is, have I found a good wear app? The built for cycling. So as a cyclist, I have found that the default notification support is really, really awesome, because when I'm biking around and I hear my phone chime, I won't check it until I'm done with my ride, which could be an hour or 2 hours later. But with just the built-in notification support, I can look at the watch, I can swipe up, I can go through, oh, it's my mom messaging me, when am I going to be home? I can give a voice reply, and that's good. Strata or whatever the crazy social racing app is, apparently has really good integration with Android Wear. I haven't tried it at all. Atlanta Cycling, if I can plug that really quick, does not have an Android app, but I use that to track my rides, because it sends your ride data to the City of Atlanta Planning Authority, so they know where people are cycling to figure out where they want to put bike lanes in. And you can also look online and see where the heaviest bike traffic in Atlanta is. All right, any more questions?
MyTracks, Google app, MyTracks, I use that quite a bit, and it does integrate with the watch.
MyTracks? Yeah. Okay, so apparently MyTracks does integrate very well with Google Watch, or Google Wear.
Which device do you have, sir?
The Moto 360.
360, okay.
Who here already has an Android Wear watch? Just 1, 2, 3. Oh, actually more than I thought.
Chris, which phone, which device?
360.
360 over here? There's somebody,
LG M360.
Okay, okay. Somebody else? Which one do you have, Bert? Galaxy Gear Live, Samsung, and there was a couple others right here. No? Okay.
All right. Last call for questions. All right. Who wants free stuff? All right.
All right. All right. Thanks. That was a great presentation. Thank you.